I thought building a chess engine would be a fun weekend project. It was not. Hello, I'm Mohammed Murad, a software developer and a chess player, and this video is my attempt of building my first ever chess engine. To be honest, going into this, I had no idea of how chess engine works. Luckily, we have Stockfish, the best chess engine ever, completely free and open source, so any chess developer can learn from it. So after hours of reading their code and doing general research, let me show you how I built my first chess engine, how I make it think, and could it actually beat me at the end of the video? Let's find out. So this was the first version of the engine. At this point, I just wanted something to work without overcomplicated, knowing just the basic rules of the game. That sounds simple in theory, but when you actually start with it, in chess you have move generation, board state, castling, en passant, forks. So the first version worked, but work is doing a lot of heavy lifting here. Let me show you here the first game. So actually I had the white pieces. I started with e4. The engine responded with d5, the Scandinavian defense. I took the pawn, the agent took. I attacked his queen. And here, instead of playing the normal moves of the Scandinavian with retreating the queen or going queen a5, the engine decided to play a brilliant move, queen takes g2. Kinda understandable because the algorithm of evaluating the position at the start was just based on material. Okay, so here is the most important part of the video. How chess engine works. It's really a simple algorithm called Minmax algorithm, which is an AI algorithm. The core concept is simple. When it is your move, try to pick the best move possible. But this is an opponent game. You have to assume that your opponent wants to make your life miserable. So he will also pick the best move. So what the engine actually does is, this is your turn, the opponent turn, your turn, your opponent turn. And in each steps, it's trying to maximize the score for each side. So when it's my turn, he's trying to best the best move for me. And when it's my opponent's turn, he assumes that the opponent plays the best move. Here we talk about depth. Depth is how many moves your engine can calculate ahead. If your depth is 3, he will calculate e4, d5, and e takes d5, which is the 3 moves. The only problem with that approach is it will grow exponentially the more depth you add to it. The more depth, the better, but it will add more calculation to your CPU and more time to actually come up with the move. That's why Minmax is really slow, and we introduce a new concept to it called Alfa-beta pruning. Alfa-beta pruning does something very important, is cutting off branches that do not matter to us. So if an engine found a line good enough and the other line is clearly worse, in ours he don't calculate it, he just delete it from the tree. This saves us a lot of time in calculating very bad lines. And since we're talking about speed, let's talk about the bitboards. So the idea of bitboard is representing the chessboard as bytes, not as physical objects. Giving a 64 binary array, which is the number of squares on the chessboard. 1 means there is one piece on this square. 0 means there is no piece on the square. It's this simple. And you do that for every piece you have on the board. And now to the final and most crucial aspect of this project was position evaluation. Because when I looked at Stockfish, it actually used the pre-trained neural network to determine whether this position is good or not. So if I had to do it, it was a very complicated procedure. I had to find the data and train it. I want to go into all of that. So I created a simple method to evaluate each position. We have 2 main aspects to evaluate. The first one, which is obviously the material. But because chess is not only about material, I gave 75% of importance to the material. And for our second evaluation method, it's very simple, just doing arrays demonstrating what is ideally the best position for each piece. For example, we all know that the knight on the rim of the boards are bad, so we give him 0 points. The more the knight is toward the center, the more points he gets. Same for the king, for example. If he was castled, we give him more points because he is safer. And after that approach is ready, everything is now into place to play actually a real game against our bot. Let's go and find out how the game went. Here I started with d4, my initial openings, c4. He played the Bongo Indian here. The downside of the chess engine is he don't know openings. And he won't go very deep in calculations to know what is the best move. Even though the engine is actually finding the moves and he struck the center with d5. Very normal play, any player would play the same here. I ruined his pawn structure, castled. And he actually pinned my queen. I took the open file. He contested me on the open file as well. Even though the pawn army on the c file is really bad, but you just kinda struggle to find the moves here. He refused to actually queen trade because it's a losing endgame. mean, it's kinda easy to know that this is a losing endgame. Of course, this is far from finished. There is a lot of points that can be improved in this engine. The first one of them is the opening repertoire. You can have an opening database for it, so you don't have to come up with the best moves in the opening, because he will never calculate deep enough to know actually what is the best move, even though he did decently in the opening part. Also, we all know that chess is solved actually after 7 moves. So there is a ready database for these endgames. So you can also give it to him to improve him more in the endgame. This was the engine. At the end, the engine couldn't beat me, but I'm pretty satisfied with the results. If you like this video, don't forget to subscribe and like the video, and tell me in the comment if you had any previous experience in building chess engines. Bye.